Hello, everyone. In this series, we are going to see the design patterns, and then we will be using those design patterns in solving some of the interview system design questions. So let us start with the singleton pattern. So I have created some notes for which you can revise the patterns quickly. So let us start with singleton. What is basically a singleton pattern? It ensures that only one instance of the class exists throughout the program lifecycle. And To access the static, to access that instance, we use the static method, which is exposed in the class. So make a singleton pattern, we have to follow some rules. Some of them are that constructor and the destructor has to be private so that no one from outside can directly create or destruct the object. Then we need to delete the copy constructor and copy assignment operator to avoid any copying of the object. Also, we need a static function which will return you the instance method, which will return you the instance of the object so that you can access the object. Then what are the ways of uh, implementing singleton pattern? So there are two ways. First is the lazy initialization. Second is the eager initialization. As the name suggests, that the lazy initialization means that we create the object when it is required. So when the instance method, the static instance method that we are talking is called, at that time, the object is created. Whereas the lazy initialization means that the object will be created when it is compiled, when the code is compiled, but it will not, it may or may not be used, it does not matter. So it will be there in the memory. Apart from this, before C++11, we used to have a slightly different approach of implementing the singleton pattern. We used to go with the double check algorithm, which is similar to other languages like Java. Whereas after C++11, we're using the static static member initialization, which is internally thread safe. So this video will be going on specifically for C++11 above. So let us try to implement these patterns, and then we will check in which one is better, like lazy or eager, and what should we use. So I'll create a class, lazy singleton.cpp. Let's write down some code. Hash include iostream using namespace. Then we need to create a class. So I'll take the example of a logger system. So I'll create a logger class. Inside this, there will be some private members, there will be some public members. So like I said in the notes, that the constructor and destructor has to be private so that no one from outside can access it. And we want to delete our copy constructor and copy assignment operator. So all of that part of the code can be kept in the private section. So I'll just write down the logger will be default, which is making the constructor as private. Then logger destructor will be default. After that, I need to delete the copy constructor. So cons logger reference it will take, and I'll just say delete. After that, I also need to delete the copy assignment operator. So copy assignment operator will return me the logger reference. I have operator equals to, which will take, again, I can make it constant, logger reference, and it will also be deleted. With this, my private part is complete. So in public section, what do we need is a static method which can expose the instance object, since we are going to create the object inside the class itself. So I'll say, let us create static method which returns me a logger reference, and its name can be kept as instance. Now I'll just create a static variable logger inst, and I'll return the inst. So the static logger inst will only be executed once when the instance method will be called first time. After that, it will not be executed again. It will always return the same instance. And internally, this is thread safe. Even if multiple threads are trying to create the instance, only one will be allowed to create it. After that, it will always return the same instance. Once this is done, let us also take a new function to display some logs. So I'll create a void log function which takes constant string reference of message, and I'll just see out log message. Since I'm only logging out some message, I'm not trying to make any changes to my class or to my object. So what I can do is I can make my function as constant function. After this, let us have int main. How do I access the logger object is by class name, because we have a method called instance which is static, which can be directly accessed using the class name. So I'll just say instance dot over this instance which is returned, I'll call the log method. So log, and let us pass string here. Let us say starting log, and then logger instance dot log ending log. You can return 0 here. Now let us try to compile the code and see whether it is working fine. So I'll say G++, lazy CPP. Let us name it lazy. And the code compiled successfully. Now let us execute this. And the logs are printing success, you can see. So now we will try to implement the eager initialization, and we'll see what all changes we need to make from lazy to eager to make it eager. Yeah. So eager Singleton dot cpk. I'll just copy paste this code and we'll see what all changes do we need to make. So since the functionality of a singleton class will remain same, it means that the private section of the logger class is going to remain same. There's no change in it. The only place that is going to have the changes is the initialization of the inst variable. So I'll not define it here. What I'll do is I'll have a member, I'll make it as a member of my class. So now when the code will be compiled, the static inst will be created, and this instance will always be returning that instance only. Now, since we know if we have any static member, we need to initialize it outside the class. So I'll say logger, logger, and with this, the rest of the code remains the same. Like again, I'll be accessing the instance method, which will return me the inst, and over that I can call the log, starting log and ending log. Let us try to execute this, and we'll see whether it is compiling successfully. C++ plus C++. I'll name it eager, and the code compiled successfully. Let us try to run this, and you can see the logs. So with this, we have completed the implementation part, but what is the actual difference between the eager and the lazy? So the point is that we can reduce the cost of construction if the object is not in use. So for that, we majorly prefer to use the lazy initialization. So that when the object is required, only then we will be using the resources. Instead of creating the resources and keeping them in memory, with this, the singleton pattern is completed. We'll also go through many other design patterns, and then we will do some interview design questions as well. Thank you.